Okay. In class 5, I had not done my homework like Paul had shown. It did not even occur to me to do it that way, to go through and set the individual bits of all the 15 counts. Um, what I looked at was an array of LEDs and how that I could take that array and make the counts. Um, so the only thing that I had to do between lesson number 5 and lesson number 6 is add a new LED and add the pin for that LED, number 9, and that was it. I hooked it up and put the pin in there, and it's running as you see. That's the only thing that I had to do with the program that I had done for class 5. So to explain that a little bit, what I do is I take this array and I determine the length of the array. Now, the length of the array is a little bit tricky because the array can contain integers, it can contain floats, it can contain whatever you want to put in it, basically. So this array is an integer array, so it only holds integers. What I did is I took the size of the array itself and I divided it by the length of the size of an individual entry, entry 0, which would be in this case 9. And that gives me the length of the array, dividing the size of the array by the size of the first entry. It'll give me the length of the array. Then I take the length of the array and I create a count that is 2 to the length of the array, 2 to the number of LEDs. And so what that really means is, for this first LED, that's 2 to the 0 is equal to a 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. And 2 to the 4 is 16. So when this LED is on, you start counting at 16. When this LED is on, that's an 8. So that's how you add those together to get the counts of what you're looking at. So you're talking about, as this transitions here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. It counts to 31 because it starts at 0. So if I added another LED, this is 16. So if I added another LED, that value would be 32. And then I could count to 2 to the n minus 1, because you start at 0. So then I go through and I initialize each of these pinouts, because these are the pins that the LEDs are connected to, and you have to do a pin mode on them. And I do a for loop to the number of LEDs to less than the number of LEDs, because we start at 0. And I set the pin mode of that LED pin as an output. So I'm setting all the LED pins up here as outputs. Then I go to this for loop, right? And the for loop is I to count. Count is 2 to the n. So it's actually 2 to the n minus 1. But it starts at 0, so it's 2 to the n. And I do a show lead, and I pass it the value of the count. So here's the tricky part. There's two parts to this. There's this bit read, and the way that I found that out was you can go up here to help and reference, and it will give you an Arduino reference to a lot of functions and values and stuff. And I found out that the bit read would take a byte and return the bits of the byte. So the second problem I had was converting from the count, the integer count, into a byte value. And what I found out is you could typecast it. So as I call show lead, I typecast it into a byte. So the count is automatically converted into a byte that the bit read uses. And then I go through and I look at each of the bytes, each of the bits, and if the bit is a high, I will set the corresponding lead pin, so the corresponding lead high. If the bit is low, I will set the corresponding lead pin low. And that's how I get the count. So it's a lot more complex than what Paul has shown. It's complex to me. I was more lucky than I was smart. But it turns out that it works. It's compact. The program is compact. The program works pretty well. And all I had to do to add that new LED, instead of redoing all those 15 counts and again for the next bit, all I had to do was add that 9 in there and connect up another LED to pin 9 and add it to the list, and that was it, and it works. Okay, thank you for watching.